Hi, accounting class. It's another great day to do accounting. Well, it's always a great day to do accounting, right? All right, let's go and get started with this problem. This is going to be a sample problem we have from chapter 10. This is actually the same problem I have in the notes. All I'm going to do here is show you how it looks in the format for the homework and how it's going to look on the quiz, so you know the exact same format. This is asking us to calculate the present value of a $100,000 5-year bond with a 6% coupon rate. So that's the rate that the bond is paying, the 6%. And it's paying that semi-annually, which means every 6 months. The market rate of interest is 8%. All right, the first step here is calculate the number of payments. I'm going to give you a generic formula up here. The number of payments is going to be equal to the number of years times the payments per year. So the number of years times the payment per year. In this case, 5 times 2 equals 10. The cash interest payment is always given by a formula. It is equal to the face value of the bonds times the coupon rate divided by effectively the coupon rate per period is a better way to say it. So the face value times the coupon rate per period. So the face value times the coupon rate per period. Alright, so this is going to be 100,000 times the 6% coupon rate divided by 2. So here's the formula, and then here is what it adds up to be, $3,000, and this is going to be every 6 months or twice a year. Discount rate, yeah, it might be a little confusing. I didn't find this in my notes, but the discount rate is going to be the rate that we plug into the tables. For our case here, the discount rate is going to be based on the market rate, and the market rate is 8%, but we're not going to put 8% as our discount rate. It's the interest rate per period. Everything's pretty much per period in this. Right, so notice that we did the coupon rate per period, now the market rate per period. So we're adjusting everything for this semi-annual term. So the discount rate in this case will be 8% divided by 2, or 4%. Now, I've asked these two questions for a reason. These two questions, I'm trying to help you use the table. This is what we're going to plug into the table, both the 10 and the 4%. Highlight them blue. All right, 10 and 4%, these are what we plug into the table. All right, so the present value of the future interest payments. Remember the 3,000 here is paid every 6 months. So we're going to use the annuity table because there's more than one payment. There's going to be a total of 10 payments. Now, you sure you can use that first table if you want, but then you're going to have 10 different numbers you have to multiply and then add together. That's a lot of work. So that's why we have the annuity table. We're just going to use this 3,000. This 3,000 is going to be the starting point of our calculation. And we're going to multiply it by the annuity, present value annuity factor that we find in the table. So we're going to think in our mind, carry these numbers in our mind, 10 and 4% to the annuity table. So notice I skip down here to the annuity table. I'm going to remember 10 and 4. Here's the 4%, and here's 10. It's 8.11090. This is what we're going to multiply the 3%. These are effectively our time machines. I know, it doesn't look cool like a sci-fi show or anything, but these are effectively time machines. They're going to take future cash flows and convert them back in time. The only reason it is still being discounted here is just there's multiple payments. Notice this number isn't 10, it's less than 10 because that's a discounting effect at this interest rate for that many periods. So we're going to use our time machine here and get 8.11090. That's all we multiply it by. And if we do the math, we get to boom. I'm going to show you the generic formula. I'm showing these generic formulas if you're using it for the homework problems. If you want the bonus, this is where we use the tables, but don't. It's the number of interest payments we use in the table and the discount rate. But we got to multiply it by the payment. So I guess it's payment times whatever we get in the table. And you plug into the table the two numbers up here, the number of interest payments and the discount rate. And you'll get your present value factor that will allow you to convert your periodic interest payment into its present value equivalency. All right, now we also have another cash flow. Bonds have two types of cash flows. They have the interest rate and the face value. we're going to take the face value, which is 100,000 at the end of 5 years. We're going to discount it back, but it's only one payment, so we're not going to use the annuity table. We're going to use just the present value of $1 table. Make sure it doesn't have annuity in it. But the amount's going to be 100,000. All right, so we're still going to carry in our mind 10 and 4, and go to the first table. Notice it doesn't say annuity up here. It's just the present value of $1. 10 and 4. Here's 4%. Go down to 10. You get to 0.67556. 0.67556. All right, the generic formula here. We're going to use the table, and we're going to plug into it the number of interest payments total, which is the 10, and the discount rate, which is 4. And it's effectively going to be the face value times that. So the face value of the bonds, which is 100,000, times the present value equivalency that we look up on the table using our time machine. Alright, the present value of the bond is really simple. We just add the two numbers together. And we get to 99,889. So we can do the journal entries. I'm thinking the journal entries might be a little bit easier once we get here. I think that's the hard part is done. So we're doing this January 1st, 2017. Yeah, if you have the printed copy, I have some of the dates wrong, but I've updated them here. Present value. Okay, let's record that cash. We're issuing these bonds, so we're going to collect that amount of cash, that number right there. So we're going to debit cash for 91,889. So we're borrowing money. That's all bonds are. It's a form of debt. We're borrowing money. We borrow 91,889, but what we're going to owe is 100,000. So we're going to owe that 100,000. That's a face value. Bonds, a simple rule is they always go on at face. They always come off at face. Always go on at face. Always come off at face. All right, but that leaves us with a journal entry that doesn't balance. So we need something to balance it out. And because there's two ways of thinking about this. Because it's on the debit side, it's a discount, or because we receive less cash than the face value, then it's at a discount. Alright, so we have cash, the discount on bonds payable, and bonds payable for 100,000. Alright, now this discount is a tricky account. Remember, it's not really a loss right now because we're going to spread that loss out over the years of benefit for this bond. So effectively the word is we're going to amortize this bond. We're going to amortize or write it off. But it's completely appropriate for your mind to think of that we're going to depreciate it because we're basically doing straight line depreciation to this figure. Now again, I want to state that this isn't the official GAAP method. The official GAAP method is the effective interest method, and I've explained that in an appendix, and it is a bonus problem for this. It's an introductory accounting class, so we're going to keep it simple and do the straight line amortization, which is very similar to straight line depreciation. We just don't have a residual value. So all we're going to do is divide it by the number of interest payments when we get to the next part. So 6 months later, we do the first interest payment. I would figure out the cash first because we already have that calculated. It's this $3,000 that we're going to pay out every 6 months. I would then think about amortizing this discount, or if it's a premium at that time, I would think about either the discount or the premium. All right, so 88111 divided by the total number of interest payments, which is 10. So this number divided by 10 is equal to $811. All right, very important here. This discount is on the debit side. And when we amortize it, we do the opposite. So we're going to credit the discount. So that you should always see this relationship. It's on the opposite side right here, you see? So the discount went on our books of the debit, so we credit it to take it off. We're writing off part of it here. We're getting rid of 1/10 of it here. Alright, then interest expense is just what you use to balance it. I gave you a formula for it, but you don't need to know the formula if you just know, hey, I got 3,811 on the credit side, I need 3,811 on the debit side. Alright, so that's the first interest payment. Whenever we pay off the bonds, I think this is the easiest transaction because I didn't make it hard. I already said the last interest payment has already been recorded. So this is very easy. It's just very similar to paying off AP. I said this time it's bonds payable. So we're going to debit bonds payable and credit cash. And they're both for face value. So this should be the easiest of the 3 journal entries. Alright, but that's the full process there. What I also want to show you, I've got this simulator for the TI-83. It's the first time I'm using the simulator. But I want to show you how to calculate this present value with a calculator. Because when you get in a business finance class, it's probably what you're going to be using. It's what I used extensively at A&M. My colleague went to Lamar. He said Lamar wanted him to do it all by hand, but I don't. They're oddballs for doing that. I think most universities do it with a calculator. Alright, so what we do if we're on a TI-83 or any type of, usually the 84s and others are very similar until you get up to like 89, which are more for like calculus and math type measures. We're going to go to apps. I guess I got to turn it on, huh? Come on, work, please. Alright, apps. Alright, it's always the first one, it's finance, and it's always the first one here. So it's apps, enter, TMB solver. And it gives you this form. What I first want you to do before you look at it, this should be the default setting on your calculator, and I bet it already is. But if it's not, we want this P divided by Y equal to 1, the C divided by Y equal to 1, and the payment equal to end. Alright, this is just by default. I really never ever use these, even in business finance classes at A&M or anywhere, because I adjust my end to be the number of periods and my interest rate to be the interest rate per period. So we handle what it's trying to do up here with these two variables. And then beginning, the only thing that are like beginning is like rent. Sometimes like if we rent a place, we pay the rent at the beginning of the period. It changes it by one period, so it changes the math a little bit. But a problem in finance would have to state this word for you to use it. By default, it should always be on end unless the problem explicitly says payments are made at the beginning of the period. So I want you to have this here by default if you're using a calculator, and it should be there already. But let's go and think about this. Our end variable is the number of periods. The number of periods is exactly equal to this number, the number of periods. So I'm going to type in 10. The interest rate, we got to be a little careful here. Let's see how I go down. That's how I go down. Okay. Interest rate. The interest rate is the interest rate per period, and notice it has a percent sign here. So it wants a percent. It doesn't want a decimal. So I'm not going to enter the 8%. I'm not going to enter 0.08, the decimal equivalent. I'm going to enter actually 8%, which is the market rate, divided by 2. Remember, we're going to discount this by the market rate, not the coupon rate. The coupon rate is what the bond's paying. That's going to calculate into the payment. But the interest rate, this is based on the market rate right here. I think if I press enter, it'll calculate it. Okay. Present value we're going to skip for now because that's what we're trying to solve for. I'm going to show you how to do this. Basically, we're just going to press alpha solve. Alpha is this key here, and solve is right here. Alright, but we can't do it now because we don't have all the variables in there. Payment. Payment's equal to the 3,000, but I'm going to go and review the formula with you. It's the face value times the coupon rate. Notice this is where we use the coupon rate. 100,000 times 0.06 times, divided by 2. Here we go. So it's the face value times the coupon rate divided by 2 equals the payment. The future value, what are we going to pay at the end of the term? We're going to pay 100,000 at the end of the term. Alright, now we have the two factors in there. Alright, so now we can alpha solve. Hey, that number, that looks familiar, doesn't it? 91,889. Alright, so this is using a calculator to do it, and I honestly think this is a lot easier once you get a handle on all the variables, but it's also very much the same thing. It uses all the same inputs that this process uses, it just says it in this way. Alright, one thing that's maybe a little confusing is the negative sign. See if I can explain this clearly. We got to think about cash going in or cash going out. I don't interpret this, the present value of it is not, in my mind, a negative number. It's 91,889. But maybe if you want to think about it this way, you think if we're the business, we're paying out $3,000 in cash. Uh-oh. and paying out 100, 1, 2, 3. And then we can alpha solve here, and it'll give us a positive figure, the same number. All right, but then you see two different ways to calculate the present value of the bonds with the calculator and with this approach using the tables. But I hope you understand this really isn't that difficult once you practice it a bit. It'll come to you more naturally, and you can see right here all the formulas if you're trying to apply it to a different type of problem. All right, that's it for today. I'll see you guys next time for the next video. Let me know if you have any questions. All right, bye-bye.